We have a reservation portal up, which you will see. All of this is running on an EC2 right now. And we have a certain amount of middleware, businessware going on behind the scenes to do pricing and finally actually to compute, soon to be able to compute the actual itineraries for our aircraft. So it's a lot of computation. It's a lot of very fancy web front end, and it's a lot of state, which we keep in Gigaspaces, and a kind of architecture that we need a lot of scalability. So now that it starts getting down to the sort of technical side of things, you can now hopefully understand what our business is, essentially moving atoms around in the form of people from seats on aircraft. But why is this so hard? Why isn't it just like any other application? Well, it's hard because Fly Me Walk is an on-demand air service. There are no schedules. Everything is dynamic. So we have to respond to customer requests in seconds, but there's no schedule. So we have to figure out not only is there an aircraft, but is there an aircraft that can go to the right place at the right time where you want it to go and still have room in the system left over for things, disruptions, weather changes, and so on. So we have to respond very quickly to customers wanting something essentially novel. It's hard because of the dynamic scaling. Obviously, demand for aircraft and use are constantly fluctuating, but it's even harder than that because disruptions can avalanche. If we have a very large weather system going on, a lot of things can be affected very quickly. And since we have to basically take customer reservations and map those to aircraft itineraries so the pilots know where to go next, all of that has to happen in seconds, even if we have a huge load happening. So we're in a situation where the variance of our usage is even greater than it would be for an ordinary system that just has customers coming and going, more customers on holidays and so on. It's even harder than that. We also have a high-growth business model. We plan for expansion to new geographical areas very quickly. Customers expect a very high level of service, so we have to be able to respond very quickly and grow quickly. So what's the solution? We looked at a lot of possibilities, including Luke Skywalker's lightsaber system, and our judgment was that we wanted to put our system, which I'll explain in a sec, on Gigaspaces and EC2. That seemed to be the best solution. Our system is essentially a Web 2.0 front end, which writes into Gigaspaces. It's a flight optimization system that reads and writes from Gigaspaces. Namely, that's the smarts, the genetic algorithms, the high-level mathematics, which understands how to take all of these aircraft and utilize them most efficiently. And then the operators, the people, the pilots and so on, they get their itineraries also via the web. So the whole system is via the web, and the whole system lives on the back end, zero capital costs for us, and all of it is centered around Gigaspaces. The solution is a scalable system, and we have to be scalable. It has to be distributed data storage. We wanted Java-based modern software. We wanted a single corpus of software, all Java, all modern, all ease of use for us to get going. And we wanted a demand-based, low-capital IT system. We don't want to spend a lot of money on IT. We did that before. Both Bruce and I, CTO and chief scientist, came from Dayjet, which had a much sort of last-generation IT system, very capital-intensive. We wanted to do it better this time. So we wanted to use cloud computing, and Amazon AWS EC2 was the right way to go. The smarts behind the system, so there's the web system, as I mentioned, and the Gigaspaces, but the smarts that figures out exactly how to map our customers, our requests, to utilizing the aircraft most efficiently is very fancy mathematics that uses genetic algorithms and so on. It's fairly compute intensive, and it also likes to have the kind of resources that we can get on an EC2. So as you can see on the upper yellow diagram, each of those verticals are a potential aircraft. All of the colored segments are flights starting from the bottom to the top. And in worst case, there'd be 83 reservations in this case, which would be 83 aircraft. Going down to the lower diagram there, that's it's 10 aircraft, and the flights, the colored boxes, have been organized. They've been packed together in a way that's extremely efficient. There's the yellow turn time in between, 30 minutes at each airport, but there are no deadheads, there are no ferrying, there's no relocations in this case. We were able to, in just a few seconds, go from very large numbers of reservations to all packed together, and then finally on the right hand we fly the schedule. So that's the kind of computation that we do, and which makes possible this kind of a air service, and all of this running, as I say, on Gigaspaces and EC2. So all of that taken together, we get an architecture that looks like this, which we'll be demonstrating. It is essentially multiple instances of web servers, which you see there on the left side in the blues. They all talk to the queen bee of the system, which is Gigaspaces data store. And on the right-hand side, our flight optimizer, that's the genetic algorithms, the fancy mathematics that does all the computation that maps the reservations to the aircraft itineraries. Multiple instances of everything, actually, of course, multiple instances, even of the Gigaspaces computation. It can run on many virtual machines, as you know. So all of this is an architecture which is very simple on the one hand and very scalable on another. So the web users on the left get serviced quickly because there's multiple instances of their Web 2.0 backend. There is the Gigaspaces keeping the thing persistent, and there's the computation, which makes the whole thing work. So once again, a very simple architecture. We can do the whole thing with zero IT capital costs, and we can scale and get this thing operational very quickly. So with that, let me move over to GAD, and GAD will actually demonstrate this, which we have working right now. Are we on?
Hi. I think there's a technical problem with GAD being on the call. He's actually controlling the interface here. So if it's possible for you to actually speak to the demo as he goes through it, that would be great.
Well, okay, what you see here is the Fly Me Walk portal. So if you're a customer and you'd really like to get from one place to another, let's say you want to go from San Diego to Palm Springs, or you want to go from Burbank to Ventura, wherever you want to go, once again, the idea is you decide where you go, you decide when you go. You just tell us right here, and we tell you if we can satisfy your request. So you're looking at the portal running right now. It's actually running on an EC2, and all of the ability to choose a one-way run trip and so on. There he is. Now GAD is now logging in. He's typing in his password, and that functionality on the back end is happening on an EC2 as you watch. This is live. He's going to type in probably where he wants to go. Yeah, he wants to go from Esimo, Santa Monica, MYF, which is an airport very near San Diego Airport. It's in San Diego. And he's now looking at, he sees that he can look at where Santa Monica is. He can look at the locations of things. So he has a lot of functionality he can do to look at his past, his present. He can do pricing. He can look at his existing itineraries, future itineraries. So all of this computation is done directly on the EC2. And the state, from one time to the next, all of that information, the state of where I've been, where I'm going, reservations, all of this information, which would normally be kept in a classical bottlenecked database, is kept on Gigaspaces, or our own space, Gigaspaces-like space. And that means that the our multiple times of logging in, we can log in, and it will have remembered everything we did. And it can also be, all of the reservations can be computed into itineraries.
Yeah, this is Shah. I would like to add a few words here about what we see here, the Gigaspaces Cloud Console, if I may.
Yes, go ahead and do that.
We see here that the whole deployment actually being done through a very simple interface, which is provided from the gigaspaces.com/mycloud site. It's basically the deployment service, which is available for users, and through a very simple configuration file, which specify the components and the application components which you like to specify. You see over there the Chiori XML. Basically, this is being used to deploy the application. From this very simple interface, you can actually see the virtual machine that has been started. We've got right now 3 virtual machines which are actually running the application. One of them is, in fact, a load balancer, which is running again also on the cloud, which allows you to load balance the HTTP request to multiple web application running on the cloud. All this is started automatically and also dynamically scaled once there are a huge amount of kind of requests coming in. Another thing that can be done over here is to add additional machines manually. You've got over there the Add Machines button, which can allow you to start machines whenever you want. It's kind of a manual scaling. We've got also for the kind of the new users few demo applications which users can start, and we've got a very nice quick tour that allows you, whoever is not familiar with the system, to go through these simple application and learn how to deploy your application on the cloud. Anything else you guys want to add over here, Gad, or someone else from the MeWork team?
Well, just that this came up so quickly. We were really surprised at ourselves. We think we're high-tech people that have now entered this the world of atoms, and we thought it would take a while even for us, and it was much quicker than we thought. And in particular, the idea of being able to have the system automatically expand on its own, because we like the idea of being able to say, well, we need 3 processors today and 5 tomorrow, but sometimes the peak load, we're sure, will come in so fast that we won't have time to manually intervene. So we're very pleased that there's an automatic way where it can look at, say, oh, we're running 80% capacity or whatever we specify, time to add more processing power. So that's the kind of thing that we like, and it's working. It seems to work very nicely.
Jim, how much time took you to, once you had the application running locally, what was the effort involved to deploy it on the cloud?
Well, I think it took us a day or something, and it's really quick. Essentially, you can get the whole thing running on your machine using local hosts and so on, and then it's just a deployment thing. So, of course, if we had to do it again, instead of taking a day, it'd probably take us a half an hour. I mean, it's so fast because it's essentially the same. It's the same process. It's the same stuff. So it's really easy. It's almost embarrassingly easy because you're used to having big IT departments, and we expect the things to take years, and they actually take days and weeks. It's kind of amazing.
Cool. I would like to add over here that we're basically using Gigaspaces as a container both for the web content, the data, and the business logic. So there's no need to start additional kind of app servers on the cloud. Gigaspaces is kind of the universal app server, which allows you guys to deploy all application kind of components into a single container. It's a single type of container, which is essentially the Gigaspaces container. And that's basically. Yeah, go ahead.
No, it's in some ways it's even better than that, because we can actually put a single Gigaspaces container together with the Gigaspaces API store. We can store our data there. We can do the web application. We can do the high cycle computation that we need for our genetic algorithms to make this thing go. We can put that all in a single container. And what's really neat about Gigaspaces is these containers, each with its own Gigaspaces functionality, can discover each other through this Genie. So there's self-discovery, and so all the other containers discover each other, know about each other, and all of that's coordinated. So we can actually bring it up as a single container, single application, and then it becomes multiple ones, and we don't even have to think about coordinating or even where the other ones are. The Gigaspaces does this thing called self-discovery. So it's a very that's really the sort of key to why it's seamless to go from a single instance on our machine, on our test machine, to 100 instances or 1,000 on an EC2. It's that self-discovery and all that work that the Gigaspaces does behind the scenes that in some sense we don't want to know about, but we do like it that it just seems to work, namely that they discover each other and coordinate, and it's logically one single data store.
Jim, it seems that you've got pretty fancy web interface. Can you discuss a bit the different web technologies that you're using and which are being deployed into the Gigaspaces container?
Well, we use the standard Java J2EE stuff. We use Spring for, I guess, a number of things, including authentication. We use the Icefaces stuff. We have, behind the scenes, there's Ajax is going on, so you have very, very fast screen updates. So we use a number of things. We use Eclipse for development. All of this open source software. So essentially, we were doing everything on open source software, very high quality open source software. And the only thing that we're actually paying for is the EC2, which of course is a utility. It can be as little as 10 cents an hour, and then of course we pay for Gigaspaces, which is also quite reasonably priced. So it's really, we're running essentially an entire IT system, which at the last generation would have taken something on the order of probably dozens of people to run it, dozens of IT people, not to mention millions of dollars in hardware. We're running the whole thing essentially for a few cents an hour. And using open source software, so we can go into detail about what that is later. But it's all out there. Apache, Tomcat, all these things are just there, ready to use.
Okay, cool.
Maybe we should answer some questions from our viewers.
So this is Mike. Yeah, this is Mike again from Amazon. And I agree, if folks would like to submit questions via the chat window, we'd more than welcome them. And in the meantime, I think it makes sense, Nadi, why don't you take it again, and you can do some wrap-up comments as we wait for some questions to arrive and go from there.
Yeah, sure, Mike. I think that the first question is more about the added value of Gigaspaces up on top of EC2. What does it really add? I would add to that question, I mean, you can basically get to the point where you could get an application on EC2 in other ways without Gigaspaces and deploy it. Why and what type of values do you get by running the application on EC2? As I mentioned in previous slides, there are a few things. I mean, taking an application and statically deploying it like in any hosting service wouldn't really require much of the Gigaspaces integration. Gigaspaces support really comes when we really need to leverage the elasticity of the cloud. Obviously, if you're running statically, you can run statically anywhere, and that's not really our sweet spot. If you really want to leverage the elasticity, this is where the Gigaspaces value comes handy. Basically, what we're doing is in several folds. We're addressing the scaling of the front end using integration with the load balancer, which means that we discover new web servers as they are added and add them to the load balancer to enable self-scaling or auto-scaling. Another thing that we're doing is we're doing it in tight integration with the data itself in order that the session state or the state of the application wouldn't be lost. So there is an affinity between the way the load balancer loads the data and the actual web servers, even if the web server changes its physical location. So if it's moving from one IP to another, we'll still be able to route the same session data to that appropriate instance and not to another instance. Another challenge, which is also dealing with how do you maintain the availability of the session, that's really on the front end. We're able to back the session data into memory resources running on the cloud. So even if the web server goes down, the session itself is not goes down and it's still kept highly available. Basically, it is being copied to another memory. So when the new server comes back, he can still fetch it, even though the actual process died or the actual machine died. On the more middle end, we provide services like grid services that was mentioned in the MIWOC to do the pricing, and MIWOC was doing it also for forking the actual task to find the route. So to do that type of operation, this type of parallel search or parallel calculations for the pricing, we provide kind of a grid API. The grid API, again, enables you to simplify how you do those type of things. You write your code as if you're writing it to a single server, and we have the implementation, the underlying implementation that takes that call and parallels it across the machines running on those servers, and therefore you get the gain of the CPU speed of each available nodes. And we'll be able also to add or remove those nodes as needed. So we're really operating not on the system level, but on the application level, and add a lot of the ability to the application that will be able to exploit the elasticity and the fact that we can grow and shrink on demand, and therefore get the value of elasticity, which is the ability to get resources when we need to, use them when we need to, and pay only for what we use. Without that, you can't really get that as an advantage, especially not in a transaction application. The other part of it is, and I'll finish that answer on that, is that most enterprise applications are really written in Java or J2E or even .NET, and they are written usually in some way of standard. So if you really try to take that application, you'll find that you'll need to rewrite a lot of that. So we're able to take those existing code and basically abstract a lot of the underlying complexity within the implementation and not expose that to the code itself, which makes the exact scenario that Jim was mentioned, the ability to move from a local standalone machine to a complete elastic environment fairly seamless, because most of the logic, most of that knowledge is abstracted from the actual code itself. There is another question. Sorry, go ahead.
Yeah, no, I was going to say, I think you were just picking it up as really we have a question about database architecture on this application.
Yeah, right. So the database is one of the common, I would say, challenges when you're trying to deploy an application, a stateful application on the cloud, and there's been a lot of discussion on that specifically. Amazon recently provided a new service which is called EBS, and basically it provides you a fast storage to enable you to store data of the database into the storage system. Unlike S3, it's designed to be much faster and much more designed to be more durable from a sense of the way the database can pick it up using standard interfaces, mount interfaces. What we're doing is two things. One, we automate the process of instantiating a database. So we can take an abstract definition using XML and basically instantiate a machine, install the database on that machine, link it and mount it to a certain EBS, all that without any manual operation. And the second thing is that we're able to scale the database by fronting the database with a lot of memory resources, like Memcache, but transactional and with ability to do search, and something that is also highly available. So on that end, we're also enabled to decouple the database from the application, and therefore we don't have that sticky point that all servers points to and becomes also the bottleneck of the application. So that in itself is also needed to when you want to deploy application on the cloud. Let's see what's other application out there.
Well, one quick thing on databases. One of the things we're very pleased with is we like to think about our data in object form, and we like that with the Gigaspaces we can store the data essentially in their original object form. But we also like that we can have that data persist in an SQL queryable database, and we can use that because we do a lot of data mining as well. We want to understand after we've flown 1,000,000 miles, well, where did we go and what did we do and what are the patterns and what's the pricing and all the things. So we can do offline analysis through an SQL type database and yet keep our data in real time in an object format.
Okay. So we have another last question before I wrap up, which is I think the question is, you have a .NET application accessing SQL Server. Where is the SQL hosted? The basic answer is that when you deploy the application, you don't have to abstract the database if you don't want to. I mean, you could use the self-healing and the SLA deployment and still keep all the application connected to the database as you're used to. If you do choose to front-end the database from scaling perspective, then what will happen is that all the SQL interaction will happen between our in-memory resources and the database itself, not directly from the application to the database. There is a mapping layer which does the OR mapping, the mapping between the in-memory data model into the database. In the case of .NET, we're using n-net, and basically what it will do is call the SQL operation as a background operation that happens, again, between the memory cloud and the database itself, and the user itself is still talking and writing objects and not really exposed to the SQL. We do provide SQL interface that enables you also to interact with the object model in memory via SQL as well. I think that's kind of is the last question for this event. I'd like to thank you all. And Sarah, you want to add that? Is there more questions?
Well,
yes. Thank you very much for attending our webinar. Mike, did you have any last minute?
No, this is Mike again with Amazon. I'm just going to add my thanks to everybody for participating. If anyone has any follow-up questions, I think we didn't have contact info here on the last slide, but if you would like to visit the respective websites, I think that there's contact us info. Nadi, do you folks have any particular method of contact that you prefer?
Yeah, basically you could contact cloud@gigaspaces.com. I think it's very easy to know. Also, I'd like to encourage you to try out the free demo. We do provide free Amazon access. You don't even need to have an Amazon user to play with the system and try your own trial. We'll actually be running on our own Amazon account. Again, we give it as a free trial, and you can freely access it and use it and play with most of the things that you've seen during this demonstration yourself.
Okay, and if folks have Amazon-specific questions, especially on the technical side, my email is mculver, M-C-U-L-V, like Victor, E-R, @amazon.com, and I'll be happy to help you as best I can. Just a heads up that I will be pretty much off email the rest of the week, so please don't be surprised if I'm a little slow replying. And I guess with that, thanks again.
Well, let me just say this is Jim Harriet also at FlyMeWalk, and we're very, very open and interested in talking to our colleagues in this space. So I'm CTO of FlyMeWalk, and my email is jim@flymewalk.com. So come and visit our website as well as send me email. And we are, once again, pleased to be part of this group to be doing this kind of work.
Okay, thanks everybody.
Thank you.
Thank you all. Thank you, Sarah.
Thank you.
Thank you.